the first power plant, the second power plant, the first power plant was what it's like beaten with. What is that? You should all the stuff, and these people are on the rest. That's a good start.
So then I would say we
No, more better than the and Zen says there's not or like
Yeah.
let's see what happens. But that's mine. Depends on knowledge. I didn't do I didn't want to teach all the story. You're from nature out. And it's the same thing. And you know what you know. Yeah. I was ready to see the first thing content differentiation. Differentiation is really Why do you think I work with art? You don't
Yes. Oh, okay. Agenda. Let me check with Gonzalo. I didn't see the message this morning. I really crazy. But so I'll tell you what. I'll chat with him. But why don't you? Because we have a moment for the agenda. So if you come up, come up to the mic, and we'll talk about whether we can fit it in. But and what is the topic?
Me and a couple of guys who have been for exam.
Right.
We put our colleagues to do that.
Okay, so let's well, like I said, let me talk with Gonzalo, but and maybe what we'll do is maybe we can own the network or the topic instead of doing slides. These slides are so let me check and we'll see. So thank you. Yeah, just in case you can do that. Okay, so I have them in my email. That's good. Thank you. I'll check. Yes, sir.
Yeah.
Oh, test it. Oh, okay. That's okay. I haven't said anything secretly into the microphone yet, so I got them. They're uploaded. Yes. Oh, that's nice.
Is anyone getting power of the power strips here? Are the power strips working? They're working there? Okay. So let's move to the front.
Now it's my machine thinking. That's okay.
Especially compared to
Excellent. Sorry about that. That was actually a plug problem. And we do have a switch. Test. And there is an office.
We can turn it off probably.
Yes, I think so.
Just slide it down. No. Okay.
Yes.
you know. just means something different.
All right, it's about time to get started. Yeah. Do we have your current? Yeah. Okay. Oh, yes. Okay, that's fine. All right. Welcome everybody to the Accord BOF. Good morning. I am Pete Resnick. This is Gonzalo. The note well, which I have made a complete eye chart except for the part that really counts, which is you're participating in the IETF. By participating, you agree that we have this bunch of processes that you are going to agree to, and that you agree to follow all of our process documents. Particularly with regard to intellectual property, take a look at the BCPs. If you don't know what the rules are about disclosing patents and the like, go read them outside and then come back. So are blue sheets going around? Oh, we have blue sheets up here. So blue sheets are now going around. Good. We have Jabber Scribes. Who are our Jabber Scribes? Ted and...
We have Ted, thank you very much for being the Jabber Scribe. And the note takers, we have Natasha, and Niklas will be our backup note taker.
Excellent.
Thank you very much.
If you are in the Jabber room and wish to have your comment sent to the mic, please put the word MIC in front of your comment. That way the Jabber Scribe will know to go to the microphone. So we have our minutes takers. And agenda bashing. I know one person said, yes, blue sheet? Oh, pens for the blue sheets. There's one.
No, at least the other one.
Okay, good.
Okay, thank you, Diego.
Thank you. And, okay, agenda bashing. I know there was someone who wanted to be added to the agenda. Gonzalo and I have chatted, and there seems like space. What is the topic for the agenda? And please, when you get to the mic, do say your name so that we know who you are.
Sure. Good morning, everyone. I'm Ling Ling from China Mobile. I'm sorry for the last minute request, but I would like to present to you, if the time allows it, a use case from China Mobile that presenting content tagging for reverse charging of encrypted traffic.
And so are you okay with that? We'll do that after Ted's talk, assuming that we have time before the discussion period.
Sure.
Okay, so we'll add you to the agenda there. That's fine. And you sent me slides this morning. I will dig them up and upload them to the site while we're going through this. All right. Anything else by way of agenda bash? Brian, do you want to say, take me off the agenda because I'm done? No. Okay, good. All right. Then our first presentation will come. Let me make sure I have the right one from Kevin. Yes, Kevin Smith. We will slide this over and magic will happen. Watch.
Maybe just a comment on the structure of the agenda. As you see, Kevin is going to give an introduction to the 3GPP architecture and how things work in general. And then we will have a few presentations, which is more like forward-looking, alternatives, things that would be done. Go ahead, Kevin.
Thanks, Pete. Thanks, Gonzalo. First of all, my apologies. I do have to run, literally run and get a flight in about 15 minutes. So I will ask any operator friends here. They may have to come up and answer any questions that I'll have missed. So, hello, Kevin Smith, Vodafone. The motivation here. Please, we go back.
Pete, you're on auto slideshow.
Oh.
These are spoilers. Don't watch these.
Don't hit play. Don't hit play.
Okay, so next slide, please. Fantastic. So the motive here is that for those of you who have ever had to read the 3GPP architecture, and I think, Bob, you were saying recently you had to read about 10,000 pages of it, it's very complex. There's a lot of stuff going on, signaling, billing, access authentication, blah, blah, blah. And so actually having a very simple view which says this is what happens to internet traffic as it hits a mobile operator and then goes out to a handset, is certainly a benefit to me, and I imagine to others as well. So what I'm trying to do here is remove all the stuff which isn't relevant, basically assume in all this that a lot of the flows have been done. A phone is already connected to the network. It's authenticated, etc. They got money in their account. But lastly, I'm not going to give you any telecoms acronyms. Not many. Right. Next, please. Right, so this is the simplest diagram you'll ever see of a 3GPP architecture. On the left-hand side, you've got the radio part, yeah, the air interface. Once that's connected, it touches with the operator, what I've called the operator internet gateway. We call it the core network, but it's the bit which sits really between the mast and the outside internet. The red boxes are 3GPP defined. The black boxes are not, but they're pretty self-explanatory. And then you're going out to either the internet, or in some cases, if you have a lot of traffic as a mobile operator from a major content partner, you can peer with them as well. So pretty straightforward there. Next, please. Now, here's a connection viewpoint. What we've got here is this concept called a bearer. It was called something else in 3G, a PDP context or something. The bearer is essentially a wrapper, an encapsulation around all of a user's IP flows. Okay, the encapsulating protocols are 3GPP specific, and they form a kind of stack, a kind of sandwich. So you'll have a 3GPP protocol, then an IETF protocol like IP, etc., and UDP. So it's quite a stack goes on here. The 3GPP protocols are doing things like saying, for this bearer, this is the IP address of the let's say the handset, the client. It's also some parts within the operator network that need to be addressed. And the reason they need to be addressed is because of mobility. So this is where the handset may hand over to another mast. You need to change the endpoints within the network, and they're captured within the bearer. Now, one side effect of this is that each user basically has their own buffer, their own queue. So they can have as much traffic as they want going into that bearer, but really it shouldn't impact other users if you've done it correctly, because each user should have their own queue. Next, please. Oh, you've got a different version of the slides.
Sorry.
Okay. Actually, no, I'll do this one. It's okay. Yeah. So one important point here is that this is what's every user gets a bearer. You can actually have more than one bearer, and the reason this was done was because of quality of service. This notion that you could have certain flows treated differently. Now, in practice today, all of the user's internet traffic goes through what's called a default bearer, the one which is set up automatically. And all that traffic gets treated as best effort. You know, there's no special treatment for it, let's say. In general, operators do not set up dedicated bearers, which is like the special kind of bearer, for internet traffic, like let's say a certain provider. They don't do that. They will do it for their VoLTE traffic. That gets treated differently, can be given a different quality of service, but not for internet traffic. So what I'm trying to say is that although the bearer is used, it's possibly not used for the intent which was originally done, which was to have these separate QoS mechanisms. Next, please. Right, so another major concept in, yes, sir.
Just one quick clarification about the bearer. You know, I'm used to hearing bearers in like radio sense. That this is like a sort of a more abstracted version, that it's more like a VPN tunnel through the network to the gateway. Is that correct?
That's exactly right. It unfortunately has a very confusing name, because we use bearer as well to mean things like LTE and 3G, but that's the way of things, yeah. Okay, so your next concept.
A clarification question. You said that if you go back to the previous slide, can you go back to the previous slide, Pete?
Yeah, sorry. I've lost control.
But I'll ask you the question anyways. You said that every bearer is, there's a sense of fairness among users, but are the flows themselves isolated within a bearer?
No, well, in theory, you can.
You can.
Well, no, actually, no. Within one bearer, the bearer has its own bounding about the quality of service treatment it can receive. So everything within that bearer is going to be treated fairly or equally. If you want to, if you wanted to treat an IP flow separately, you would need a dedicated bearer, a separate. Bearer.
So then fairness is at the level of bearers, not at the level of IP flows.
Correct. Yes.
Thank you.
Absolutely. Okay. Yeah, so volatility and mobility, obviously you've got with a radio interface, you've got a lot of signal to noise going on. As you move away from the cell tower, the signal attenuates, you've got buildings and things in the way, and this varies rapidly as the handset, the connection moves around the cell. So you've also got other users joining the mast. That means more load on the mast, more stress on the radio resources. And basically this means that the throughput available at the mast is very volatile. And so these contribute to delay and loss, meaning, right, so I've got a slightly different version of this slide, but I'll go through this one. So you've got, at the radio interface, you have what I colloquially call layer 2.5 functions. And what these do is they attempt to account for this volatility and mobility. So these are doing things like, so the focus, yeah, and I've got apologies here for the acronyms, but you've got services which handle handover. So this means that when you move from one radio mast to another, you need to make sure that the flow continues very quickly, including any buffers which are built up, etc. Yeah, so there's a helper for that. You've got the radio resource controller, which does things like make sure that the appropriate resources are being given out to the appropriate handset. And by that, what I mean is if a handset is in a very weak signal area, you shouldn't be allocating a huge amount of resources to it because it can't use it. And this is happening very, very frequently back and forth. And then finally, you've got two kinds of retransmission going on. You've got the MAC layer retransmissions, which are fast. And then you also have this system called the radio link control, which does reliable retransmissions. And this is to account for delay sensitive and loss sensitive traffic. What you should do as an operator is try and tune these two so that you're accounting for the different flows going through the cell, making sure that the retransmissions are appropriate for that. Now, because of these retransmissions, these two kinds of retransmissions, they can affect. Yeah, this basically, I would call this as kind of being out of joint somehow with TCP flow and congestion control. So you've got noise and retransmissions going on at the radio layer. Now, those can be interpreted or misinterpreted as congestion by TCP endpoints. And meanwhile, you've got two kinds of retransmissions going on at the radio layer, and maybe that's not being fed back into the control loop, and maybe it should be. And so what can happen is that the network can proxy TCP to attempt to account for this. So you can get these TCP proxy solutions which say, we will talk to the radio layer, find out what retransmissions are going on, and attempt to track ACKs or get in the middle of the TCP dialogue accordingly, which is not ideal, but it's kind of a side effect. So basically the network and the endpoints at the moment aren't working as well as they could do on flow control. Bob?
Just for everyone's information, Ingemar Johansson has written a internet draft to explain the congestion control in 4G and 5G, this part of it. If you want it, it's draft-Johansson-cc-4-4G-5G.
Yeah, at least 65% of this presentation is stolen from Ingmar's draft. So yeah, it's an excellent draft. And yes, we put some links up about that.
And if someone would paste that URL into the Jabber.
Right, so this is an oft controversial topic, and this is what the network has, within the core network, which manipulates traffic. So we've talked about the radio scheduler, and I've mentioned that because of the use of default bearers, it doesn't tend to prioritize one IP flow over another unless it's VoLTE or, in a rare case, on a dedicated bearer. But then within the core network, just talked about the TCP optimizers and why they might be there, which again is maybe not ideal, and we can work together on a way to improve that. You've also got some, you can either call it optimizers, middle boxes, or just shenanigans. What's going on here? So in the 15 years or so that I've been working in mobile operations, you've had functions which write headers. And some of those are just used within the network itself, but some of them may be going out to the broader internet, which isn't ideal. Rate limiting. Now, that might be a global policy. For example, BitTorrent. If you see a lot of BitTorrent activity going on in a cell, a long-lived flow, it might be throttled down to a low level. But then there might be, in certain countries, rate limits applied to certain flows arbitrarily. And then finally, content blocking is something which operators, as I explained at Marnew, it's something that operators are regulated to do. So they have to have these filters in here for things like court order blocks, or maybe adult parental controls, etc. So the content blocking stuff is as much a regulatory issue as it is a technical one. It's a architectural constraint, we could say. Rate limiting ideally shouldn't have to happen. We could, look at things like more advanced AQMs, etc., to obviate the need for that. And then writing headers really probably shouldn't be done in this day and age. Next, please. So basically, the thrust of this is myself and also a group of GSMA operators. We're in a group we call SMART, or Smarter Traffic Management, which says there should be a better way for the basically the IETF and 3GPP communities to work together on this, to account for the issues at the radio layer, to account for things like the fact that the radio layer will have very high buffers. The reason it has high buffers is because if you've paid for a lot of radio spectrum, you want to make sure it's utilized very fully. And so you have a nice full buffer, which means that when a radio resource becomes available, you start shoving data into it. But then, of course, big buffers aren't great for other reasons. They don't play well with TCP congestion controls, for example. So working on topics like that. Also, we'd like to see some further work on SPUD, for example, which is shuttling information back and forth between networks and endpoints. And that can include information from the network, stuff like the amount of bandwidth which is perceived to be available. Mobile throughput guidance could be one element there. The dual QAQM from Bob, we just come from the L4S meeting earlier where we showed support for that. And then finally, for operators to start reassessing middle boxes. A lot of them have been in there for a decade or more. Are they still needed? Have things like adaptive bitrate means that operators shouldn't have to have video optimizers anymore, for example. So we'd like to provide some education on that. And then the final one is at Marnew, one issue was of content providers having issues with debugging customer problems. So a customer would phone them up, this doesn't work, but it does work. We've tested it. It works on this operator. But of course, operators being different, we need to provide some sort of tracing, I think, back to content providers to say, well, this is maybe why it's not working on our network. I think that'd be very useful. And many others. So the strap line, as it were, of this GSMA Smart Group is improving customer experience without breaching customer privacy. So any breaking of TLS or anything like that is completely off the table. We want to work together to achieve that goal, like I say, without breaching privacy. Okay, so I've got about 3 minutes for questions, after which I'll probably hand over to any other operators who would set up.
Please be fast and concise. We don't want Kevin to miss his flight.
You really don't want him to miss my flight. Or you'll have to deal with my wife, which you really don't want to be doing.
So first,
you didn't minute that, did you?
What?
Okay, what I just said about my wife, you didn't minute that. Okay, good. Right,
okay, we start with the back mic. Go ahead, please.
Yeah, Matt Ford. I just wondered this GSMA group, how sort of open its activities are. I mean, because it seems to me the interaction between mobile operators, the GSMA, and folks at the IETF is going to be key to addressing some of these issues. And
absolutely.
So yeah, can you talk a bit more about that?
Yeah, sure. So we've got one ID out, which is network management of encrypted traffic, which says if you've got, this is a big fear for operators. We have suddenly seen this great rise of TLS going through the network. What do we do about it? And we provided a draft, which is, yes, network management of encrypted traffic, which says, well, this is how you do it without doing any man in the middle or anything like that. So we want to do more of that, and we would do it just by producing drafts. But then, we're happy to talk offline as well. It's no problem. So, okay, yeah.
Jana Ingar. So I'm trying to relate back the things that you say here back to your talk, the rest of the talk. And you say that transport hints between network and endpoints make sense. So in your picture that you had the TCP optimizer all the way down to the user, where do you see the transport hints actually fitting in?
Good question. I know what the hints could be, as in what the information model could be from the network side. Exactly where it fits in, I think that's up for discussion. I mean, we've seen the SPUD, things like UDP headers.
Oh, not precisely where in the headers, in that picture of functional units. Do they fit as exchange of information between the UE and the TCP optimizer, or the UE and the radio scheduler? Or...
Oh, I see. Well, from the network side, we would look to provide information, and it would be provided to the endpoints. But beyond that, no, I think that's up for...
So you're not thinking about consuming information, you're thinking about providing it?
Yeah.
Okay, thank you.
Channeling for MCR Soho, could the steps in the bearer channel become visible by a TTL decrement as routers? That would help in debugging.
Yeah, great suggestion, actually. Can we have that available to... Great, thanks, Ed. I'm going to have to go now. I must apologise. Could I ask one of the operator representatives maybe to come out and field some questions? I can see a few, so if no one steps up in 5 seconds, I'm going to name a name. Yeah, Natasha? Or Dan, or Chris, or Freda, or Diego?
Okay, thanks. Thank you, Kevin. Thanks a lot. There were a couple of guys on the mic. Aaron, do you have a question? Maybe someone can address?
Well, yeah. Sorry, go down.
Yeah.
You were in front of me, weren't you? Okay.
No, I'm supposed to answer you.
Oh, you're supposed to answer. Okay, so I'm Aaron Falk with Akamai. So at the Marnu workshop, there was a thick explicit statement, and it certainly was embedded in Kevin's great talk about the impact of end-to-end encryption and how it affects operators' ability to manage their networks. And so I haven't read the draft that he referred to, which is, I think I hope somebody that actually gets shared. That wasn't an IETF internet draft that he was referring to, right? About managing networks. Oh no, this is coming out of GSMA? Okay. Okay, good. Well, so I think, so the question I have is there still, do people still believe in the operator community that end-to-end encryption inhibits or breaks the ability to manage the networks, or having had some time to synthesize the feedback from the workshop and whatever's in this draft, do you feel like there's a clear path forward?
That's fine. Dan Drutzer, AT&T. I think in general, there is still a sense that the current methods of network management are being disrupted by lack of visibility of type of content. That doesn't necessarily mean that it's, in fact, HTTPS has been around for years, decades, right? So it's just that the proportion of traffic has changed. So the optimization that Kevin was talking about, now it becomes less and less efficient. And so that's why we're very open to alternatives to network management that will not break any user privacy, but at the same time provide with the same or even better levels of information that will allow us to better manage the traffic. So in regards to what Yana was asking, I think it's both ways. You are asking if we're interested in receiving information and giving back information. I think it's both. At least I'm speaking on my own company's perspective. And that we may not have the same solution that we're using for these two. But we do see a lot, and in the talk that Kevin gave about the fact that we are not raising separate bearers. That doesn't mean that it's not possible. It doesn't mean that we're not open to it. The one thing that people need to understand in this room is that turning up and down bearers on a per user basis is not an easy, or it's not, it's costly. It's costly on multiple levels. So you're not going to be able to turn on and off for various types of traffic. You either have them or you don't when you turn on your phone. So that's something we need to keep in mind. This is not something we are randomly just kind of create. Thank you.
Pat McManus, Mozilla. I appreciate the presentation. Always learn something on a presentation like that. So I attended Marnu, and one of the outcomes of those sessions I thought was pretty clear, that when we had these discussions about other pieces in the network, whether it's the PEP proxies or the classification proxies or the drop-in proxies or the et cetera proxies, we lack an open quantification of how much that actually matters to the network. There are a lot of assertions about how much that matters to the network, but there wasn't a lot of data in that. And that then leads to the arguments of how you address these shortcomings if you can't quantify them. And one of the outcomes was pretty clearly to me that the 3GPP side of the house was going to present that data in hops, now known as maps. This was euphemistically known as Kevin's data. That was not fair to lay it simply at Kevin's feet during the session. And that was really a precondition, as I understood it, of a BOF like this, where we're trying to delve into the technical details of the problem. And I appear to have missed that presentation. I haven't really seen that data.
Hey, Natasha Rooney, that was an action point that I had. And we have been working hard to try and work with the operator members and other members of GSMA to get data together to bring in. It's very, very difficult for a number of commercial reasons, which I feel are a bit silly in some cases, but are there, and so we're working in a number of ways to get that data. I'm still working on it. Is basically the suggestion here, or the answer. It might turn out that it's not going to be hard data, that it will be something more along the lines of studies, which hopefully gives some more information on exactly how and where the problems are happening and what they're doing. But a lot of these organizations are very careful with the data that they part with, so we have to be a little creative with how we get that. So sorry for the delay.
No, and thanks, Natasha, for looking into that. And I mean, we understand that this type of performance measurements is sensitive to some operators or vendors. So yeah, but anything you can get your hands on that'd be great if you could share it. Thanks. Next one.
Tom Herbert, Facebook. So I think I can understand the loss of information and how that probably does disrupt the ability to manage these networks. But the context that I'm missing is what exactly is the information that's needed that's now being encrypted that we're being asked to kind of expose to the user or to the network? Is this more than just, oh, it's video or not video, or are there other things? Presumably before the encrypted world, it could be an open-ended list of things being extracted from the data, which I don't have a sense whether or not that was happening.
Perhaps I can answer to this question.
Yeah, please go ahead.
One example of information are the hints that are going to be defined by the HTTP working group about the width of the screen, the resolution, because these are used by optimization function, which adapt the content according to the size of the screen or the resolution.
By the way, I mean, the acoustics in this room are quite bad, so try to speak everybody slowly and distinctly. Otherwise, it's even difficult to understand for us. So one thing, we have a few more presentations, and some of these questions, I think we could actually have them as the general discussion. If that's so, please hold them. If you want to ask right now, like Jana seems to want, go ahead.
A clarification question on the architecture specific to Kevin's talk. Is it possible to have multiple UEs per bearer? And is it possible to have multiple bearers per UE? Okay, so I think the answer is no to the first and yes to the second.
Exactly. Okay, thank you. And I mean, the next questions we'll have them. We have plenty of buffer at the end for the general discussions, but we would like to go through all the presentations first. So I think Jana is up. Yes. And by the way, the presentations we added, the presentation we added to the agenda is going to be before Ted's presentation. So just, you know, a small change in the agenda. Jana. Pete is driving there.
Sorry.
Yeah.
Oh, cool. I can see my slides here. Jana Iyengar. I'm going to be talking about a solution space that I'm proposing. No, I'm not proposing. I'm advocating for, and I recommend that operators try before we move forward. Thinking about what more information can be exposed. I think this I call this the zero-bit alternative, fully knowing that there is information that is there, so it's not truly zero-bit. Nevertheless, the name is catchy, so we'll call it zero-bit and we'll run with that. Next slide. So this comes out of the description for Accord. One of the problems, as I see it, that Accord is trying to address and operators are often trying to solve is efficient use of the often volatile radio bearer. And this, next slide. This is usually a problem when you're talking about the radio link, which is considered to be the scarce resource. When yes.
Just a clarification, the bearer is probably the most stable thing in the radio. It's the resources that are being allocated and all that. Because as you heard from the previous presentation, the UE starts with a default bearer and it dies with that.
When you say stable, what do you mean by stable? Do you mean stable
It's
like
stable in the sense
UE?
that you initiate the default bearer every time you. So just terminology,
Okay.
picking on that terminology.
Yeah, so I'm probably going to be a little off on terminology because I'm not completely up to speed with it. Bob.
This is probably more a question for you. In a fixed network, each user has a queue, and that's part of a hierarchical scheduler, and their capacity is varying all the time because of other users' traffic. Are we talking, I assume we're talking about an order of magnitude or two order of magnitudes different levels of variation of capacity here because we've got less users per cell. Is that true? Because typically in a fixed network, you've maybe got 1,000 users that are in that scheduler, so it's more averaged. You know what I mean? As well as the radio resource changing.
Don't know the answer.
Ted Hardy, just a plea to people to let the speakers get to the end of the presentation and then have the question.
It's my talk, Bob. Don't ask other people questions during my talk. Sorry. So usually the resource that the network is trying to maximize and use well or optimize use of is the radio bandwidth that's available. And when the radio link is the bottleneck, queue buildup occurs near or at the radio link. And somebody there, depending on exactly where the queue buildup is happening, has to decide which flows to schedule onto the link. This is a scheduling problem. I've not heard in the past this being described as a scheduling problem, and I am arguing that it is a scheduling problem. We also do not want queues to be persistently large. Yes, we want them to be large enough that you don't lose this use of this resource when you have it available. But you also don't want it to be much larger than it needs to be. This is a queue management problem. Next slide. And I'm going to present one example. This is not the only one, but I'm going to present one example of an AQM mechanism that actually directly attacks these problems. FQCODL is a hybrid packet scheduler and AQM algorithm. It is in last call in the IETF right now. This provides traffic isolation between flows. The AQM in there, the CODL, provides load delay, and there's no ECN marking required, which makes it immediately deployable. This is a solution that's available. Now, I want to be very clear about this. The previous slide, I talked about queue build-up and having to schedule packets from flows that are in the queue. This is always the problem. You have drop tail. We've had AQM in the past, but that's old AQM, and that's dead AQM, and that was not so good AQM. We have extremely good AQM now. This works, and it's fantastic, and it's going to solve world hunger. It can definitely solve your problems. Bob.
Do you want to finish your talk, or
I can
queuing up?
If it's a clarifying question, go ahead.
No, it's not.
All right, then wait. Next slide. See, now you're pressuring me to finish the talk.
Yeah.
I have 15 minutes. I'm going to use it all. Just a bit more detail, just so I'm giving you a little bit of a flavor here. If you want all the detail, very well written draft, please go read it. It actually has, it's not that long, and it's actually, the mechanism is cute and wonderful, and you will be able to understand it if you read it. But just a bit more detail here, that FQCODL allows for sparse or new flows to actually get scheduled immediately. And flows with continuous backlog are scheduled after sparse flows. What this means, what this translates to, is things like web, DNS, flows of that sort get very low latency. Things like YouTube, video conferencing, things that have a lot of backlog and use a lot of bandwidth end up getting scheduled later. This allows for a low latency traffic to get low latency, and throughput intensive traffic to not care about latency. So it's a nice, cute mechanism. You can play with this scheduler too. This doesn't have to be the only one you implement. I'm saying this is an example. This is one of the ones that we have here being in last call. A very important point here, there is no explicit classification that is required. The reason we can do, there is no explicit classification required of the traffic. A traffic classification in this context, in my opinion, is classifying traffic based on content, not based on 5-tuple. I think 5-tuple as a flow is something that we generally assume to be the case. But I should have said no explicit content-based classification is required. And that's important. That's an important thing, because much of what we're talking about here, much of what we talked about in Marni was a response to encrypted traffic. And what content-based classification mechanisms have been used in these networks traditionally, you may not require content classification mechanisms, because you can deploy solutions that work without requiring you to know what the content type is or what the traffic characteristics of that particular content type are. I'll refer you to that draft for more details. Next. The second general thing that concerns operators and is a problem for operators, and not just operators, this is a problem in cellular networks in general, is that TCP does not perform well on these networks. This is why, as Kevin pointed out in his architecture, there are TCP optimizers in the network. This is very common, and this has actually, I completely believe it, that it's helped in the past TCP flows from completely dying in the network, because the vagaries of the cellular network don't do well, but don't really give TCP a good sort of network to work with. But I will offer something else as well here. Next slide. The congestion control landscape, which usually dominates TCP behavior in these spaces, and the optimizers, TCP optimizers that we're talking about, are often trying to address shortcomings of TCP congestion control. There's work that's been going on in congestion control as well that is not reflected currently in TCP flows, but there is a lot of interest in the industry in evolving congestion control to meet the needs of today's mobile networks. Given the amount of increase that's happened in mobile devices, in mobile traffic, and the rapid increase that's happening now, there's a tremendous amount of interest in content servers to actually work on congestion control problems in mobile networks. These do not come from content servers, or these come from academia. Nevertheless, they are very good and very strong data points in a evolving congestion control landscape. Next.
And do you have a question, or are you just excited to discuss with Bob?
I can think of it.
Okay.
This is, I don't expect you to be able to read all of that. That is not material on my slide that I want you to read. But you can look at it later. I'm not giving you a reference. You can look at these papers. You can look them up. They're available. This is from NSDI 2015. Next. Veris from SICOM 2015. These are brand new congestion control mechanisms that are tailored specifically for mobile networks, measured, and these are extremely exciting. I'm personally interested in trying them out, figuring out how useful they are for cellular networks in general, and I think everybody in this room should be, because it solves some major problems that we've traditionally had.
May I just interrupt? Or?
We do have a question.
Okay, sorry, Martin Stiemerling. I think you're looking way too much in the current past. I think if you go back to 1995 and look for cross-layer TCP optimization, you're going to find even more stuff on this.
Oh, absolutely. I'm not. Do you want me to put more things on the slide?
No, it's just like a general, because it's good to look for new stuff, but there has been a lot of prior art before.
Oh, fair. I mean, I was not trying to go for like a what happened in the past 2 decades thing. I was just trying to point out that absolutely tailored to mobile networks of today, we have these congestion control mechanisms that have been proposed. Next slide. So the 0-bit alternative, therefore, that I propose is, let's do content and protocol agnostic modern packet scheduling and AQN. Let's do modern congestion control. And then let's try and figure out why this does not work, if it does not work, and try to answer questions of what needs to be done next after we've tried these out. Thank you.
Thank you, Yana. Bob, go ahead.
Hi, Bob Briscoe. I think I very much want to agree that once you've got
then do it. Agree.
Good packet scheduling. Once you've got packet scheduling between users and AQM within the user, you've very much knocked down the problem to a very small scale. What I disagree with is saying it's a scheduling problem within the user. Because scheduling...
absolutely. I'm sorry. I actually said that in the FQ Caudal slide, but go on.
Right. Within a user's traffic, scheduling has a policy behind it. Even if it's everyone equal, that's a policy, right? And once you start scheduling individual flows, you have to have a policy for how you do that. And if you have a policy that says, right, I'll give them all equal capacity, what that's saying is, I have a policy that the end system is not entitled to schedule its own flows because I'm doing it. It's end-to-end principle.
So let me argue that you can't schedule your flow deep in the network.
No.
You can schedule your flow if you're aggregating it within one unit, so to speak, like quick or speedy or HTTP2, where you have multiple streams going over one TCP connection, then you can certainly schedule them.
I'm saying when TCP chooses how far its packets are apart, it's scheduling.
I agree with that.
Yeah. And when a video is going at different rates or whatever, if the network has to know that's a video to schedule it against a TCP flow within that user's domain, then you're getting back to content measurement to know that's a video. And so you have to, what you've potentially got is something where you want to help the user, but not overpower them in the network. And that potentially could be flow policing, but not scheduling or scheduling. Yeah.
You're trying to, okay, I think I understand what your point is. Your point is basically isolating flows means that you're doing something that's more than what you need to do.
Yeah,
I agree with that.
Taking out some really bad flows rather than scheduling them all.
So I think this is a nuanced point. If operators are deploying this and arguing that FQ is maybe the right thing to do or not, I think we should have that conversation at that point. My general statement with FQ Coddle was also to say that you can use that sort of FQ for user level isolation as well. And you could do Coddle within each user and allow for the user to schedule their flows how they please.
Yes. Yes.
So yes,
Yes.
that's why I
Yes.
specifically said with FQ, I said not just flows, but entities. They'll do, and those entities could be users as well.
And one of the other reasons why I wouldn't want to go to per flow for the user, and for FQ Coddle was largely designed with a residential gateway type box in mind. When you go to an RNC, radio network controller, or a box for a large number of users, I mean, we were doing this thing that Kevin Smith mentioned, dual queue, to reduce the number of queues per user from, we had 5 in our network, down to 2.
I'm going to pop the stack.
And you're talking about putting 1,000 in per user, and that's something at that scale when you've got thousands of users on a box that you don't want to do.
So I want to pop the stack a bit and say that I don't think we should talk about FQ Coddle specifically. That was an example, right?
Yeah.
But the argument was to do AQM first.
AQM, yes.
Yeah.
Yeah.
So we can talk about FQ Coddle at scale and how to make it work or not, or maybe but we should do that later, I think.
But the reason I'm very concerned about this is that the whole buffer bloat sort of marketing that's been going on has been confusing AQM with FQ Coddle. And we need to stop doing that. No, confusing the word AQM and saying FQ Coddle is AQM, and there is no other AQM.
So the first statement is true, the second is false.
About that. Yeah.
Are you saying that FQ Coddle is not AQM? Also, yes. I agree, but the AQM work, okay.
And to repeat what's not at the mic, he said it's a scheduler also, and that's an important distinction. And so please do make your comments at the mic when you make them. Go ahead.
Hi, Chris Seal. I'll take a slightly different point. I agree with the premise of queue management and things, but the statement that TCP does not work well on wireless, well, I work for an operator and I have no evidence of that on the broad scale. And we don't do optimizers, and we measure passive TCP retransmissions, and they're low. The additional point I'd make is that 4G and 3G are very different. And anything you look at, 3G had a load of state transitions where if you did certain things, you'd be upgraded to a faster radio bearer. There'd be a 1-second timeout whilst the network reconfigured. That's all gone in 4G. So when we really need to distinguish the two, as it's a very different beast.
That's can you repeat who?
I'm Chris Seal. I work at Hutchison.
Hutchison, excellent.
Yeah, so, but I mean, I can't say across all our territories, but certainly a lot of the primary territories don't use TCP optimizers. Interesting. Effectively, we've found no value in them.
Thank you.
Xavier Marjou, Orange. As it was said by Bob, in mobile network, the total bandwidth is restricted or constrained. And I think it's even worse because depending on where the device is located, regarding to the access point, is it close to the access point or very far away from the access point in the edge of the cell? The cost in terms of bandwidth of carrying a byte, an IP byte, is not the same as for a device which is close to the access point or far from the access point. Typically, far from the access point, it will cost much more in bandwidth rather than for a device which is very close to the access point. So greedy devices at the edge of the cell cost a lot, a lot for all the other users. Basically, they use nearly all the bandwidth of the cell. And does the AQM alternative solve this point?
Can you repeat your last piece? I'm sorry,
Yes, I
couldn't hear the
wanted
last-
to know if the AQM alternative can help in making a difference between devices that are very costful in terms of bandwidth because they are far from the access point and the other ones which are close to the access point.
I'm not sure. I don't know.
That's a radio scheduler problem. It's not the
No, because if you put a low delay for the same type of content, even if the content is not that big, it will not be the same cost in terms of bandwidth, of low layer bandwidth, for the overall cost of the
to be clear, the AQM is going to only help you when you have packets in a buffer. If you don't have them in the buffer, it doesn't change anything. If you can schedule them, that's the only time you should have them in the buffer. Did you want to say, Tim, something? Go on up.
And just to note, we're not badly over time, but we're 10 minutes past where we thought we would be. So just keep that in mind as you make your mic comments. We've got plenty of discussion time at the end if it's a more general topic. Go ahead.
Mia Kulevin. I want to say the work on congestion rule that's out there optimizes for a mobile scenario. However, the problem here is that usually in a mobile scenario, you have one queue per user, and as soon as you have to compete in the queue with different users, it doesn't work that well anymore, many of those proposals. And so that only works if you can basically guarantee that your bottleneck is in the mobile network, which is very often the case, but might not be always. And so that's a little bit dangerous to actually deploy those, as there are many of those.
I generally agree with that sentiment. I think that a lot of the proposals that they're going to see are going to assume that the mobile network is the bottleneck. That said, I totally agree with what you're saying. I think that that's not an unsolvable problem with these congestion controllers. I'm not saying take them out of the paper and deploy them as they are.
So the only solution I came up with to this problem, and it also makes to some extent sense because the link characteristics in the mobile network and in the fixed network are very different, is deploying a TCP proxy between there. It's not the worst idea to do it. Maybe, I mean, if we find a nicer solution, I would totally go for it. But like, if we have those proxies, I think what we at least need is to advise people how to do it correctly.
So I don't think that it's true that so PCC, for example, is actually not tailored to mobile networks. That was the second paper I showed. That's actually a more general congestion controller, and I think that absolutely has convergence properties that are actually quite usable. I don't know if they've tried this out on mobile networks, but it's an extremely promising one from what I've seen, and I would like to see it tried out. My point was that
then there's still the deployment issue, right? Because you have to implement it in the endpoints, and if you don't implement it in the endpoint, then you still, if you don't have it in the endpoint, you still need a proxy.
And that might be a fine deployment strategy.
And the other point I wanted to make is about AQMs. So all the AQMs we have right now try to minimize buffer. However, in the mobile network, because it's so different, you need a little bit of buffer because you always get a certain amount of capacity at a time, and then you don't send anything for a while. So it doesn't really match up that well as well. So I'm not saying that these aren't good starting points, but I don't think we're done yet.
Oh, absolutely. So if I suggested that I have a solution that I'm going to sell, then I'd go make a startup and sell it to these operators. But I think there's a lot of work going on in both spaces. To actually make them fit the mobile framework, we need to do some work, and that work starts with experimentation. Before we actually, even PCC for that matter, I would like to try it out first. And to your point of there's a incentive, a deployment problem because you have to get end users to come. There's a lot of incentive aligned with that already. Content servers want to do better with these networks. I don't think that's a hard sell to get them to come on board if there are good congestion controllers that are, if there are newer and better controllers that will actually utilize mobile networks well.
It's really a chicken egg problem because people will not deploy it if they are not sure that it actually will be better. And if you're not have it deployed, then you can't show it's better on the actual network. You can show it in simulation, but that's not the same.
We can do experiments.
And I want to make
We
very
can do
short
experiments on the real
third
network.
point is you can do even, because it's very constrained resources, you can do even better if you have more information. You can probably tackle the problem that make it work, but if you even would know something about the content, you could do it even better, I believe. But the question is, how much more information do you need?
How much better do you need to do?
Might be one bit.
Just one bit better? One bit better than what? And that's the question I'm asking. I'm serious about this. We don't know how well you do here. So we can only say if it's better after we've tried these things and said this isn't good enough.
We're gonna get one more question and then we'll move on and we can continue discussions at the end. So, yeah. No.
Tokyo Helen Jacobson. I just wanted to push back a little bit on what Bob's saying. I'm guessing he's not surprised. So yes, FQCoddle is a scheduler. Yes, it has policy. If you have 2 or n constantly backlogged flows, it will enforce complete fairness between those. But oftentimes you don't have all your flows backlogged all the time. And so sometimes you can get this benefit. So I would just say, we've seen a lot of things in the home where this actually helps, even though you have these constraints. And the second thing is you don't actually need 1,000 flows to do this. As low as 16 per batch per customer in this case has been enough.
Yeah, I agree. Yeah, these are the weeds we want to not get into now. But.
All right. Thanks, John. Brian, you're up. Me.
Yes. Yay. Hi, I'm Brian Trammell, and I really hope that everything John had just said works, because that makes life a whole lot easier. I'm also really happy that we did find a way to have an AQM working group meeting this time, even though they weren't meeting here in Buenos Aires. I'm going to talk about what if that's not enough, right? Because the reason that might not be enough is really back to actually Miriam made the comment, right? The internet is made of lots of different kinds of networks. And if we start trying to figure out how are we going to make this particular thing work for this particular segment of this particular network, you're trying to solve sort of a multivariable optimization problem, and lots of the things are going to react to how you're doing that. So I hope that works. I'm not sure that it will. I'm going to talk about another idea. I'm not sure that this is going to work either. Next slide. Why do we need a bit, right? So we basically have, these AQMs. If we do good congestion control, why might we need a bit to be able to say, okay, we'll treat this traffic slightly differently? Because in all of these sort of networks, as you catenate them together, pretty much all of them have been built with some basic assumptions about loss. Loss is bad. This is where buffer bloat came from. I don't want to be the guy that built and sold the box that lost the packet, because traceroute's going to tell me where that box is, and if all of the packets drop at that box, I'm going to buy another box. It's bad for the guy that sells the box. It turns out that when we start moving to these new congestion control algorithms in this AQM world, transports are becoming more sensitive to latency. Many of the applications that we care about that we're building on top of this internet are sensitive to latency. All of the ones that are going to be driving all of this traffic onto the mobile networks are sensitive to latency, right? We're not sitting here continually downloading Linux kernel images to our iPhones. That's not fun. That's not interesting. We have that because it has a really nice screen on it. We need to get media onto that screen. Right now, the approaches that are used in the mobile networks, Kevin said this better than I did, but I'm gonna boil it down. We guess which traffic is which. We look at the packets and we say, this looks like this kind of traffic, this looks like this kind of traffic, and we make a basic assumption that the traffic is not trying to evade detection. Sometimes it does, right? So over-the-top VoIP providers have gotten very, very good at, even without encryption, not being able to be figured out from the DPI. So if this loss latency thing is one of the big trade-offs, Why don't we put a bit on the packet to do this? And there's actually been a lot of work in this space. I think Bob actually had something where we say, okay, well, if it's ECN marked, then we assume that it cares about latency. And if it's not ECN marked, then we assume it cares about, maybe that wasn't Bob, that was somebody else. Bob did like 3 steps above that. So next slide, please.
Hold it.
I can keep talking to this one, but.
Keep talking, I'm getting there. There we go.
So one way that we could do this with the DSCP, so now we're going to have the first session of the TSV working group again, and we're going to go through DSCP really quickly, and we're going to do this in a way that's going to anger people who understand it, because I don't really understand the depths of it, and I also don't really agree with it as a way to do things. So this is DSCP in review from a skeptic. We have these 6 bits in the IP header. They're in slightly different places in v4 and v6. That allow classification of traffic for per hop OS. These are called per hop behaviors, PHBs. It's a stateless way to do QoS in the internet, right? Each router is configured, it sees one of these code points, it knows what to do without having to keep any per flow state for that. There's 5 types of these, but there are 4 that are important. There's default, which is best effort traffic. Just do whatever you would do if you had no marking at all, or if you were in a non-DSCP world. There's class selector, which is a way to sort of trap out and have backward compatibility with the stuff that Ted's going to talk about, which is sort of a simple priority way of doing things. This packet is more important than this packet is more important than this packet. Drop these first. There is expedited forwarding and assured forwarding. Expedited forwarding is really these packets are really important bit. You get low loss, you get low delay, you get low jitter, and these are implemented with a priority queue. So the EF packets actually jump the line. Voice admit is EF with a contract that I think is implemented out of band that somebody actually did admission control to say you get to send voice admit. So there's bits of the architecture that hang off the side here. And then assured forwarding is you have bandwidth limited forwarding guarantee. So basically, if you keep your rate on an assured forwarding flow below a certain threshold, you have a guarantee that your packets won't drop with big fuzzy scarecrows around guarantee. If this is completely wrong, DSCP experts, please come throw tomatoes at me now. Good, tomatoes are hard to find. We looked at this and we said, actually, none of these do what we want to with respect to trade-offs. Next slide. Because all of the bits are kind of like, my packets are important, my packets are very important, my packets are super important, my packets are extremely important. How many people can tell the emails that they get from other engineers as opposed to people who are not in engineering in your organization because of those 2 little bang marks in your MUA because of the importance header, right? That means somebody clicked a button and now I can safely ignore that, right? There's no technical content. That is the no technical content in this message flag. We have the same problem with DSCP, right? Because these are useful inside a single network where there's no borders that you have to deal with. But when you get DSCP marked traffic from a network that you don't control, the fact that that AF needs basically configuration of these limits per class for this bandwidth limiting, and those limits might be different on network to network, means you can't pass that. EF is basically that 2 bangs flag. Yes, this is a very important packet. Make sure that it gets through and let it jump to the head of the line. No content that I'm interested in. We have to bleach that off. Both of these are ways that I can disadvantage all of the other traffic on the network, right? Somebody has to pay for that. If you're going to deploy these in the internet, and I understand that there's some drafts, maybe they're in CDNI, I forget where. I've seen some drafts about basically doing interdomain DSCP, but there's always an understanding that there's a contract behind that, right? There's got to be consideration. The backside of that trade-off is somebody's paying somebody. So let's try to use these bits in a slightly different way. Next slide, please. So here we define 2 bits. There's the low bit, which is the I prefer latency to loss. This is kind of this standard assumption, right? This is the please don't drop me even if you have to stick me in a queue for a little while. The new bit is the I prefer loss to latency. That is the I am, oh, I see a DSCP expert coming up to the mic.
Well, I don't, we're DSP amateurs anyway. But we're probably going to the best you're going to get. Cullen Jennings from Cisco, and I work a lot with this stuff. I mean, I think I agree with what you're saying here, that this is what the only thing that practically works in something is something that has the incentives not to lie, right?
Yeah.
That there's ups and downs.
Keep in mind, I'm saying this is the only thing that might work.
Might work, fair enough. But this is what DSCP is in practice, right? Okay. And so, you know, the priority, like if you say these bits are really special by indicating the traffic as audio traffic, for example. There will be downsides to indicating that. If you try and send it, there will definitely be only a little bit of traffic that's allowed to send that way, and your results will probably be much worse than best effort if you try to send all your traffic that way. So on every one of these things, in the practical deployments, people design incentives into it to make things work right. The you know, the other thing is you're often trading off against applications on your same device.
Yes.
Right. And I think I always hear people say, well, it couldn't possibly work across from one service provider to across two different organizations. But why would it work inside a single organization but not across two organizations to me? No one ever has a really good answer to that type of question. So I think the reasons people provide that it won't work across organizations actually all apply inside a single organization just as strongly. And that, you know, I mean, why don't we all set the TCP timers to completely different values that completely give me individually much better performance and not everyone else? And there's a lot of reasons that doesn't happen. People could do it. I mean, it does happen on rare occasion. You can police it. You can find that it's happening, and you can go stop those people. And it's similar to this thing. So I'm not against where you're going. I just think that what you're describing here is actually DSCP in practice. It's just there's some bits that indicate more or less those exact things you have on that slide. And there is incentives to lie, but there are a way of catching people who lie and not very big incentives to lie, and there's downsides to lying.
Okay, so I would suggest I would suggest that we talk offline, actually. Right, can I finish? Because I have one more slide that I don't think has been overtaken by events. So yeah, so basically, actually, I think this is pretty clear then, right? So the idea is that you allow yourself to trade off of your own device. And when we say I prefer loss to latency, I might be a transport that prefers a whole lot of loss to latency, right? Like, so in order to actually set this bit, you essentially have to be both loss and latency sensitive in your congestion control. You need to be a little bit, the transport needs to be a little smarter in order to be able to get stuff through, because yeah, Cullen is right. If everybody sets this bit, then you get much worse than best effort. You need to have a transport protocol that understands that and has that assumption designed into it. There are points in the configuration space for certain congestion control protocols that currently meet this, they currently have sort of this property, but this is kind of a thing that we're advocating for future congestion control and future transport protocols. Next slide, just to get through one particular implementation. We go and we pick 2 bits out of pool 3 in DSCP. This is this bit of the DSCP code space that is reserved for experimentation and internal use, but explicitly reserved for future standards action use. So squat on this, but please don't squat on it too hard, I think is what the IANA, I mean, it doesn't actually say that in those words, but that's what it means. One of these is the low bit, one of these is the la bit. One real quick way to implement this is you have 2 queues at likely bottlenecks. You have your standard short queue for LO, and you handle it right now as if it were marked default. And then you have an extremely short queue for LA. We believe that this is, in terms of other ways to mark traffic that would cross network boundaries, this is probably the most quickly deployable, because there's a lot of routers out there that let you put stuff in a queue based on the DSCP code point. That's how it's implemented. These are, if you either have access to it through the configuration, or it's not a whole lot of code to make that happen. And if we cut parts of this code space out, the firewall rule that right now says mark it DF and recompute the checksum changes to mark it DF unless it's one of these 2. You can mask out the bits in order to jump to that rule. So there's actually router configurations that you could use to make this happen today. Will it work? I don't know. I wasn't super convinced of it when I came up. I'm less convinced of it now talking to Cullen. I think that's my last slide.
I believe it is. As my high school debate coach used to say, use word economy, please, with your comments.
Okay, so as TSVWG chair, where we do DSCP work, we do have some interconnection work going on. When you say easy to deploy, I would say painful to deploy, and this extremely painful to deploy. You're taking 2 new diffserv code points from pool 3. This is not easy to do. It might be honorable, but there are other ways to do this. So
I would suggest that we put this one bit in the spud header, but that's a different BOF.
And there's some ETN bits as well that might signal this. That might be fun.
Because we haven't overloaded those enough yet.
All right, Bob Briscoe. I'm gonna say that the problem we're facing here, that, and like Kevin described the mobile network, in a particular user's queue, you've quite often got all low latency traffic or all all low or all low all at once. You haven't got a big aggregate here to do the trade-off on, because it's a very low utilization of that particular bearer. And so, I would argue diffserv is not the answer to a problem where you haven't got anything else to overtake.
Absolutely, I would argue that based on traffic mixes from the early 21st century, that observation holds. I don't think that observation is going to hold in the future. We're seeing a lot more concurrency on these devices. We're seeing, basically this is the WebRTC case.
No, but we're talking about concurrency per user.
Yes, yes, we are.
Even if you see a lot more of it, there's none at the moment. So the average number of flows when a new flow starts on a bearer is less than 1. So it's not a diffserv's a trade-off between 2 things. Right. And when you haven't got one of those things there, you get no difference.
Yep.
Diffserv was designed for aggregated networks, and then it got sort of abused. Next, the problem of latency versus loss, or the insight that that's a trade-off, I don't see that in many applications. Web applications, loss becomes latency. It has to be repaired. All the short flow applications, loss is latency. In voice, there's graphs that the ITU have done of mean opinion score for loss versus latency, and both of them are impairments to the voice. So that it isn't a case of, oh, I love latency or I love loss. I don't like either of them. They both tend to turn into the same thing, an impairment.
Tom Herbert, yeah. So along those lines, I think in the architecture of the application really would have to be the application setting this.
Yes.
Which means, and especially since we're already doing encryption, anything below that can't do classification.
Right.
Which means as an application, I have to decide which to use. And I don't see, this doesn't provide an SLA, obviously. So. Yeah. Which do I choose? And I think the only thing I would do is try one, try the other. Whichever gives better performance is the one I could use.
So you already have the socket. That's another thing that makes this takes this from impossible to deploy to very painful to deploy. And that is, you already have the socket options for these on most stacks. And I would expect that most of this stuff would be hidden behind a library interface. You would make this choice as an application developer by choosing a library that you use.
Well, right, but it's still, somebody has to decide.
Yeah.
And it seems like it's based on empirical data, which is better. The other thing that you probably would want is we could extract information from TCP layer that might give us a hint. So as Bob said, if I'm experiencing TCP loss, that may manifest itself to the application as latency. So saying that I'm preferring latency over loss wouldn't make any sense, because loss is the source of latency. So I should be saying prefer loss over latency.
So
or the opposite.
The question that I would ask there is how much of that is an inherent part of the problem, like inherent part of the communications problem that we're trying to solve, and there are laws of physics that keep us from being able to get out of it, and how much of that is a artifact of the currently deployed base of transport protocols in the internet. And I don't know where that set point is, but I'm pretty sure it's not all physics.
Yeah, I think part of it also goes back to the fact if I'm running multiple congestion control protocols over the same connection, inevitably they're going to interfere, they're going to cause conflict, and then configuring or optimizing that is going to be really difficult with such limited information.
It's an internet. It's hard.
Okay, and
why
let's
we all-
leave the mics where they are. That's it for people on this topic in any event. Front mic first.
Dan Drutza. Thanks for the presentation, Brian. And I think you're hitting on some of the key requirements that we had. Initially, and the things that I proposed in Marnio are very much in line with what you presented. I think the difference, the devil is in the details, and maybe what you did with picking on DSCP is kind of a proof of concept rather than the end state. And I also think that between the one bit, just like you said, between the 1 bit and 0 bit, I think they're complementary.
Absolutely.
What I don't, what I want to make sure is that this this 1 bit classification is an immutable part of the flow. So using DHCP, it seems to me that is a thing that others can override, and that will defeat the whole purpose of classifying content. We work in RTC Web, actually, the whole idea with the, and by the way, this is not about prioritizing, it's classification. So we need to make that distinction. But I think the idea is that you want to give a hint as an application provider, and just like you said, it can be hidden by behind the stack that is used on the client side. But you got to give a hint about what is your traffic like. So then we can actually put it in different queues or different, you apply different schedules. And actually, this is extremely important for us and for the UE, because the way we actually optimize, it has an impact on the radio and battery consumption. So I think the principle is good. I think we need more work on.
I'm not proposing that as an actual implementation at this point, and I absolutely agree. And I want to underscore. I'm going to repeat something you said. I think that this is parallel work. I think that figuring out how many bits you have to use if you've already given up on doing it with 0 bits is something that we should look into at the same time as looking into it with doing it with 0 bits.
Back mic.
Well, Schott, Deutsche Telekom AG. Just a short comment as an operator. You mentioned that you want to have a mechanism over networks. Was it a...
No, I was pointing to someone behind you.
Yeah, okay. And I only want to mention that you control the borders anyway. Yeah. Our experience is that different operators use different scheduling schemes, also different code points. So from that point of view, we desire to control because we need it for queue management. Second comment is that quality of service, even this mechanism is sophisticated, doesn't create bandwidth in that way. So we need to do some over-provision anyway, and the more queues you have, the more difficult it is scheduling management. And my comment is, if you want to create here a new scheduling, quality of service scheduler, deficit round robin combined with some new mechanism on the mobile edge, then probably this might be innovative, but I'm wondering whether you really need to recreate the diff-serve code point model, because we as an operator, this TOS-bit RFC 79121 or DSCP, we want to control it anyway, and we have an already legacy implemented quality of service schema and have no interest or see no benefit really in changing this. On the edge, especially in this per flow, okay, I agree, probably there are some more sophisticated call flows, but end-to-end overall, there are already implementation in place, and we don't really need to change this.
Sorry, when you end-to-end, you mean from one end of your internal network to another end of your internal network?
Exactly.
Okay, so per segment.
It's per segment, but you have at the border.
End-to-end means something different in this room. I just wanted to make sure.
Yeah, okay. But if you want to go to other networks, you have agreements, and also to fulfill quality of service or SLR agreements.
And as long these are, you can monitor this and it's in the contract negotiated, and then you're done and everyone is happy. Sorry.
Miriam?
Yeah, Kulevin. So I was thinking in the meantime how to map this a little better to mobile networks. And I think what you want there, and it doesn't matter how you signal information, but if you have those two traffic classes, you actually want to open two bearer per user. And you use two different queues here. And you have one very long queue. And as I said earlier, you need the long queue because you have the network works differently. And for the other bearer, you have a very short queue, but that means if you don't have packets in the queue, then maybe you get some capacity and you don't have anything to send, so you cannot fully utilize what you have there. However, if you phrase this a little bit differently, what you say here is basically, I need low latency. If you delay my packets too long, I will throw them away anyway at the end because they're not useful for me anymore. While on the other class, you say, I need low loss because I will for sure retransmit the packet. So if you throw it away now, instead of buffering it, if it's possible for you, you will see it again.
So if I can rephrase what you're saying, the first part of what you said. So what you're saying is that we can basically, on the bearer segment of the network, use something like this to be a bearer selector. So a way for the application to tell the radio, do this. We have a problem on the downstream then, because you got to get that bearer selector for the reverse traffic to come through, but there's probably, that's interesting. Let's work on that.
Spencer.
Spencer Dawkins probably not speaking as a transport AD.
Probably.
I think the way this is shaping up in my mind is that we're going to have to do three things. One is have the high bandwidth exchanges that we're having here and more exchanges on mailing lists like Accord. One is to look at any information that Natasha's able to pry out of operators from GSMA, appropriately anonymized and dumped into places like MapRG. And one is, I think, we have to remember that there are things like experimental RFCs for a reason. I think we're going to have to push on all three of those fronts to figure stuff out. I think we have really smart people. I think we're all kind of touching different parts of an elephant. And I think we're going to have to push on all three of those in order to get where we need to go. Probably not speaking as a transport AD.
I shall reflect on that, Cohen. Thank you.
Thank you, Spencer. Okay, Martin.
Unless you can no longer speak as a transport AD.
No, right. So my name is Nadine Stiemerling. I'm a retired AD, so I'm not an AD anymore, but I'm here nonetheless. So what I would like to see and where I would like also to contribute, if possible, is that somebody builds something with the tool set you have right now and runs tests with that to see if we have just enough. Because I think we have ECN, we have DiffServ, we have a few IQMs. We have maybe even people who own mobile networks where we could get a slice to test this, because you can get slices there, so that you don't disturb other people, meaning get your own bearer, for instance, your own APN, and run a test and come back with numbers to say, look, it's working, or it's working at that scale, or it's saying it's not working, we need to fix it.
I think this is discussion we should have after the end of the talk, so yeah.
Can I take like 7 seconds?
7 seconds, go.
With another hat on, we're working on essentially an observatory of exactly these types of impairments. If you have data or would be interesting in us helping you to design, this is me, Brian Trammell, within the MAMI project. If you'd like to help us design measurement studies for that, please drop us a line. Thank you.
Okay, thank you, Brian. So we're going to be having the e-commerce presentation now before Ted's presentation. Would that work for you?
Right now, Ling Ling, is that okay?
Can you present right now?
And
okay,
we looked at the slides, and I think some of this, at least in skirting ways, we've covered. So you could probably run the slides quickly, and then we'll do a quick Q&A.
Hi everyone, my name is Ling Li. I'm from China Mobile. Until this morning, I am not aware that I'm entering another AQM meeting, so sorry. But I'm presenting another use case, maybe a little bit, a different story. It's actually about source tagging for reverse charging of encrypted traffic, and it is a joint work from China Mobile and Alibaba. Next slide, please. Actually, right now we're experiencing a changing lifestyle with e-commerce. The e-commerce has been online shopping has been replacing on-site shopping globally, and in addition, online promotions has become, national shopping festivals. For example, Black Friday in US, and we also have 11.11 China for Alibaba, and 6.28 for Jingdong. So what it does is that actually what we concerns is that the e-commerce has also been changing operators' lifestyle as well. What it means is that there has been vast volume of I'm sorry for this typo, asymmetric traffic from a handful of e-commerce giants to a large portion of our subscribers within a very short time frame, maybe of days or hours duration. Next, please.
You have a screen there if you want.
Oh, I'm sorry.
Easier.
Oh, this is new to me. So actually, we came up with this idea of this appealing business model. So what we've done is that we have a talk with Alibaba and proposing that maybe we could do reverse charging during the e-festivals. The idea is that, we have the ICP instead of the subscriber pay for the data traffic to its websites for our mobile subscribers for the purpose of further promote customer participation in a win-win situation. So the implication is that, the charging gateway sitting between the operator's network and the ISP's website and our subscriber has to identify or differentiate the traffic flows and do the reverse charging for these traffic to specific ISPs that we identified and negotiate beforehand. So actually the problem is not that hard for reverse charging because we have been a long time doing this reverse charging for our telephoning service. What is challenging for us is actually we have to have ways to identify web traffic for specific ICP websites. At that time, before encryption, actually we have considered various ways for this identification. For example, we can do layer 7 DPI based on URL to identify the traffic, and we could also do IP address based identification for our charging gateway. Next, please. However, our life changed overnight as Alibaba has migrated to, Speedy by the end of the year 2014. And by that year, actually, at the beginning of that year, we actually have been negotiated billions of dollars deal with Alibaba, and we're hoping that we can offer this new service to our subscribers during the 11.11 festival. But, a week before that, we were informed that Alibaba has migrated to Speedy with encryption, with TLS. That means that all our prepared solution don't work anymore. So, looking closely, that the layer 7 DPI won't work because of the encryption. And also, we tried with the IP-based identification, but it won't work because the solution is not performant enough for our charging gateway, as we have to manually configure a very enormous IP address force for the nationwide CDN network for Alibaba. So this solution didn't work either. And there may be potential alternatives for that. So we were considering, 2 years ago. One is that out-of-band tagging, which means that we can we might do some piggybacking during TIS and handshaking to has the source tagging identify itself to our charging gateway. And another way is that, we could do in-band tagging. So we would have the traffic carry on its own source tagging and, outside below TLS encryption layer. And that was the idea that before I gave birth to my second kid, and after half a year when I came back, after my parental leave, I was very surprised to see that, none of this has been deployed to our network and provided to our subscribers. And the answer is even simpler because that, both sides would want to have a standardized solution so as that we can be relieved of the burden of side-to-side or case-to-case negotiation with our content providers. So that is the sole reason that I'm standing here telling you this long story. So next, please. Oh, I forgot that I have a summary slide. Next one, please. Okay. So actually, I'm standing here to ask you this question. So would ACOT be interested in solving this use case? And if the people, within this room are willing to help with that? Thank you.
So, and I guess if you think your comments will be more broad or part of the broader discussion, let's leave them until after Ted's discussion. Okay. And if it's more directed to this, let's have a few now. Back mic first, yes, please.
Okay, this is Dapeng Liu. I'm from Alibaba Group. I'm the co-author of this presentation. Just one minor clarification. So we are not trying to deploy, quick at current stage. We just deploy TLS. So that's a little difference, but with the problem, I think it's the same. And I also presented this in the UTA working group on Tuesday, I guess, but people don't like, to extend TLS to solve this problem. So we are thinking whether, in this both, is there any other ways to solve this problem? Indeed, it's actual requirement. It's a real deployment scenario. Thanks.
Thank you for the clarification.
Go ahead.
I think this is a use case that has been discussed. The only thing that will require additional consideration is the trust involved in this tagging. Oh, yes. And that's the only thing I wanted to point out, because this can encourage people to, reverse charge. So you need to be able to have mechanisms to trust this type of tagging on your charging end. Thank you.
Yes, right. Actually, I skipped a slide. Actually, I had a paragraph on that.
Oh, I can go back.
Sorry.
No problem. If I can find it.
Yes, this one. So actually what we required is to enable reverse charging, and there may be, the last paragraph, there may be further security implications that to be considered.
I wasn't even talking about, not even talking about middleware, poisoning. This is literally saying I'm eligible for reverse charging where I'm not as an endpoint. So if I grab the tag for whatever reason, how do I know that that's actually, maybe it is related.
Jana.
Sorry?
Go ahead.
Jana Iyengar. I won't get into the technical details of this. I don't know how you could do this reliably and securely at all, but I want to make a general statement about this. This is referred to as a zero rating. Others of you may have heard about troubles that Facebook and other companies have had in countries such as India with trying to give internet access to folks and reverse charge to the content provider for free internet access. This absolutely skirts and is squarely in the space of violating net neutrality. And I'd be very, very careful to discuss bringing something, I'd be very careful to bring something like this into the IETF.
Just a quick point to Jana. I mean, what's IETF's problem with that? I mean, if it breaks net neutrality, then
this topic, let's cut off for now, and we can get to that in the broader discussion if we need to.
Thank you.
Go ahead.
Pat McManus, Mozilla. I would suggest that the fact that TLS obscures the information you are looking for is not simply a inconvenient coincidence to be overcome, but is actually probably the point of TLS in this scenario, and that's a huge objection to this type of solution. I think this proposal actually does a very nice job of underlying the dangers of all of the I will signal my piece of content to the network types of solutions.
All right, thank you. Ted, I believe you are up to bat. And you only have negative 15 minutes, so.
Oh, good. Negative 15 minutes. I'll see how fast I can recover time. In part because I don't actually intend to give the slide deck that you see in front of you in any real way. So look, it's the Internet Protocol, the DARPA Internet Program Protocol specification from September of 1981. Just remember how long ago that was, and note especially the word DARPA in front of it. Next. It's sometimes kind of interesting and instructive to go back to the beginning, in this case, section 3.1 of the beginning, where the toss bits are explained. There you'll see this precedence list. Routine, priority, immediate, flash, flash override, critic, ECP, inter-network control, and network control. Everybody who feels like they should be seeing Justin run through here in a scarlet blur, you're thinking of the wrong flash. Next slide. Now the reason some of those things were here for use with this, which I know Fluffy has seen and many of the other people in the room have seen. This is our friend the Audubon. This was a military telephony system, and that F and FO you see there are flash and flash override. Next slide. Within a network, those bits were used for, next slide. Admission control. Doesn't that sound so circuit switched? Yes, yes it does. And ejection. I don't love you anymore. Get out of my car. So, what does that mean for us in this BOF? Don't even go on to the next slide. Because I think what it means for this BOF is kind of actually been pulled out by Brian, who was talking about bearer selection. Because the problem that we're dealing with here is kind of an interesting one, because there are 3 stages of grief we have to deal with. In the very last stage of grief is where Jana and Bob are bickering about whether this is a queuing problem or a scheduling problem, or whether they just need to get a little counseling and relax, right? And because they're all in this tiny little network that's been set up for them, maybe none of it really matters within that tiny little network. The stage of grief before that is but I used to have signal and I've lost signal stage of grief. But the ultimate stage of grief is really the one in bearer selection. Right now there are 2 bearers. There's telephony and everything else. And what those bearers actually mean is the size of the transport block you get and the number of scheduling slots you get in the scheduler, right? So in a radio resource control context, what we're talking about here is a piece of data that says how big your link is and how fast it will go. That's a little bit different than where Bob and Jana are arguing. And yet that's the data that's what the data that the signal we've lost was used to do. Assign the number of blocks and assign the size of the blocks. So I think where we really are is kind of coming back and saying, this kind of all sounds all very circuit switchy, and I'm kind of uncomfortable. It's okay to be uncomfortable, but realize that from the history of the DARPA Internet Protocol all the way forward, we've always had a bit of this tension between people who needed to be able to treat their network in resource fashions that kind of seemed a little bit more like virtual circuits than datagrams, and those of us who think about them in terms of datagrams and the flows across the network in those terms. Once you get past the radio layer in one of these core networks, you have all of these different virtual circuits behaving as if there were little VPNs inside a large-scale IP packet network. And the fact that there are VPN networks inside it doesn't matter from any of the congestion control or other things that Bob and John are worried about. But when you're way out on the resource side, figuring out how big a virtual circuit to set up in terms of radio blocks and radio schedules, it does make a difference. And it's at that tension that I think we really are. So as we think about what we need to do to solve this problem, let's be careful to recognize whether or not we're actually going to be trying to provide a signal to the RAN about what size transport block and what schedule the radio access network needs to provide, or not. Because if we're not tackling that, then we have one set of solutions that we're pretty sure we can experiment with and find something. If we are tackling that, we have, I think, the bearer selector problem that Brian identified. How do we signal to the network what bearer characteristics would be useful to meet the needs of the flow that's about to come in? If we keep those two things distinct, I think this becomes a lot more tractable. And the more we make them mezclado, in the local term, the less tractable this will ever be. By the way, that super spy car is available on EB. It's an Aston Martin toy. And I'm now saving up for it because I really, really want it. Yeah, no, that's James Bond. That was actually a James Bond car. And so that's a bad guy getting ejected from James's car in the Aston Martin in one of the 70s versions of the James Bond. Bob.
Right. Just firstly, a clarification question. I believe it's true that a user cannot ask for another bearer and get more than other users. Their bearer is a hierarchical thing. Their bearers are within a bearer for the user. Yeah?
The current specification in 3GPP, I believe, allows a single UE to get multiple bearers, and it is up to the operator to decide how the bearers relate in resources. It is certainly the case now that you will get VoLTE bearers if you have a voice over LTE bearer, in addition to your data bearer that is distinct.
Yes, that's true. Yeah. But assuming that that's an exception, and it will be more likely that if we're giving bearers for different sorts of data traffic, then they're going to be within some hierarchy where a user can't get more by just asking for more bearers, then I don't think it solves the problem that we're talking about.
I don't know why you would make that assumption, and it certainly would solve a portion of the problem in any case.
It was designed to give users multiple bearers to implement different characteristics, but if they just don't know how to map the traffic to the different bearers, they just use one.
And I'm presuming, by the way, that the current line might be on TED or might flow into the broader discussion, and either is fine.
Please let me know when you want to flow into the broader discussion so I can go sit down.
Maybe this goes back to what I'm saying about one of the reasons why, maybe one of the reasons why there's only one bearer per user isn't just that it's difficult to know which one to ask for, but it's what I said earlier about the level of multiplexing is so low at that point that it's unusual to have two bearers. Even if you had two different sorts of traffic, it's unusual to have them going at the same time. And it's more likely that they're not going at the same time, and then there's no difference.
And I think Brian's point earlier that the type of traffic where that will increasingly be the case is WebRTC and similar, where you know you have multiple kinds of traffic which are running at the same time. But there's kind of a queue building behind you, Bob. So maybe we should take your next question.
I just want to say we have done measurements on this, and when you are running video, it is not running all the time. That's the point. It's only running a very small part of the time. This is multiplexing in time. You've got a different model in your head, as if networks are like toothpaste tubes where your traffic goes on forever. It does not. It's
so
time
I see my beloved colleague Cullen Jennings in the back of the thing, who would be happy to talk to you about how audio and video flows work in the ideal network. Saret.
And Cullen does a dance.
Suresh Krishnan, just to clarify something to Bob, okay? So when like a UE attaches like to a mobile network, it gets default bearer, okay? It's specific for traffic, okay? It's got like some kind of QCI. So if you want like other bearers, you set up a dedicated bearer for it, and the bearer can have a guaranteed bitrate or not, okay? That's chosen by, again, the QCI. QCI is like kind of like a it's like a table. It has like different numbers. Each of them says like, I want this kind of latency characteristics, this kind of like packet loss characteristics. Okay. So how the bearers of a different UE interact with each other is not necessarily hierarchical for the UE. Okay. It's something that's decided by the operator. And the reason why people cannot keep asking for bearers is because it probably costs money. So the back pressure being applied for somebody to like not indefinitely ask for bearers is probably money, or like a requirement to use like a service that somehow pays money to the operator. So that's how like you stop people from just keeping asking for more.
And aside from being devilish, is there anyone who wants Ted to continue standing here, or shall he sit down? Anybody in the line want to talk to Ted directly? Yes, okay, so
standing, please hum.
Are we humming for whether
no,
should continue standing?
So, is yours a more general comment? Because maybe have Mira make her comment so Ted can sit after.
It's a specific. I'm trying to understand the bearer situation
right
too. So, so do I understand this correctly that right now we basically UEs get a default bearer, but no other kind?
No, they may also get a voice over LTE bearer.
Okay.
If they're engaged in telephony, which is mediated by the operator. Other kinds of telephony, like WebRTC, would go over the default bearer.
Understood. So pretty much all the data traffic is currently going over
modular, what Suresh just said.
Except for VoLTE, yes. So the rest of it is all WebRTC, including WebRTC, is all going over the data bearer.
Right, unless they've gone and done the QCI things that Suresh talked about to set up a dedicated bearer, which is unusual but possible.
That sounds like a good thing. I mean, you were talking about having different kinds of bearers. So let me ask this question again, right? It seems like the world that we have right now is that of a shared, sort of everybody gets the same bearer, you're in a shared resource, rather than you can get into a different world in the future where you possibly have different bearers and so on. But the current world is one where it is a shared resource, is it not? The bearer is a shared resource.
No. The bearer is a shared resource within the set of flows for a particular individual, and that individual uses the transport block size and the number of slot cycles to create what is in essence a virtual circuit until it reaches the rest of the packet network.
Okay.
Now, so it's a shared resource for a particular UE. Now, the question that I was asking before is, are we trying to solve the problem of indicating to the network what the appropriate number of transport slot cycles and transport block size is, because that's one problem, that says, what should my bearer look like, whether it's shared or, as the QCI would have it, an independent bearer, or are we trying to solve the problem of when a single virtual circuit is being used and we are trying to manage the different parts of the flows not stepping on each other in the WebRTC or other cases. I simply suggest these are distinct problems and we need to be quite clear about which one we're trying to solve, because some of the stuff that we were hearing before about radio resource control was in effect about what size bearer needs to be set up given the media traffic or the other aspects of the traffic going past. And those are distinct.
I completely hear and understand this now. Thank you for explaining that. I thought we were trying to solve the second problem. And it may be possible that that the first problem needs solving as well. I would like to find out exactly what. Yeah, thank you for explaining that.
So I agree how you tackle the problem in the network, the mechanisms used in the network are very different. However, I don't think that you as a user or somebody who sends traffic wants to say, I want to have this time frame of sending this bandwidth. You don't want to tell the network exactly what to do.
Yes, if I have to type in how many transport slots or what block size I have, I'm pretty sure the user's not going to get that right.
No, so what you want to tell the network is what's the characteristic you're expecting for your traffic. And that might be the same information for both of these networks. The mechanism that follow on this, based on this information, is very different.
So in SPUD, I think the way we talked about this was we don't want to tell you what kind of traffic it is. We want to tell you what kind of network treatment we want. And I think that the loss sensitive versus latency sensitive is a what kind of treatment do we want signal and appropriate for that network. There is a question, and I don't have an answer to that question, so I get to sit down whether you have a follow-up or not, is there a different signal I need to tell the network that isn't what kind of network treatment, but how big a network do I need? Because there may be cases, maybe not many, but there may be cases where if I know that I need a network of a specific size to accomplish my task, I'd prefer to get admission control than the wrong network. Or I'd prefer even, in some cases, to eject somebody else from the network in order to get me the network I need if I really have the capability of doing flash override. Not that we're trying to rebuild Audubon. Although apparently it would amuse Spencer. So I think, having said that, I get to sit down. If there's nobody else,
you can sit down.
Oh, thank you.
I still want to add something, but you don't have to stand there anymore. So I think, yeah, so this latency signal might be one thing. We might need more information, so I agree fully here. I just want to get back to a point Tom Herbert made much earlier, is that this information, this is the interface between basically the transport and the network, and there you might talk about latency or whatever. The interface to the application might even look different. And here, something like, I need low loss might translate into, I don't want any loss at all, I want reliable transport, and then that's something the application can work with. I just want to make, I don't want to go into the details of what signals we need, just want to make a difference here, that this is talking to the network might not be the same language than talking to the application.
Very
Hi.
dramatic, Brian.
Brian Trammell. Ted, just come up here and join us in the mic line. It's much warmer over here. Actually, first statement, what Maria said with a minor tweak. The language that we talk to the application is almost certainly not the language that we talk to the network, because the network is not a sensical statement. We're going to have to give different signals to this mobile segment, this bearer thing, than we're going to have to give to what comes after that. Because once we've solved the bearer problem, it's like every time they build a new road in your town, they're just moving the traffic jam around, right? So this is not a problem we're going to get to stop solving. And I think we need an architecture for doing this that allows these signals to get to where they need to go, wherever that happens to be in the internet this decade. Declarification statement. I apologize for this in advance. As I was looking at this, thinking about this bearer selection problem, right? So let's assume that we're in a mobile network and we have end bearers and we have some way for the application to tell us which the end bearers are. You can actually almost model this like multipath communication, just with the fact that two of the paths share the bottleneck, which is where those two bearers come together back through the radio access network. And it seems to me we've done a lot of thinking about how to do scheduling in these multipath areas that might be applicable. It also might not. I have to go look at that.
Roland Bliss, KIT. Yeah, I just want to comment basically on Brian's presentation. So DiffServ is not only DSCP, right? So it's also about domains and boundaries and policing. So this was maybe a little bit too simplified, but yeah, it may work in the sense that if you need to signal from the application into the network in case of a resource conflict, what kind of trade-off do I want? That may really work. I mean, I also second Bob's comment, if there's no other traffic, then there's no trade-off, right? But in this sense, this may be part of first, let's say, approach, but basically, I think you need several mechanisms, and we have to distinguish them. One is more or less indication of intent of the application to the network. Second is classification. Third one would be differentiated handling inside the network, basically maybe queuing, scheduling, things like that. And so, and last but not least, maybe also different transport protocol, right? I mean, TCP has its problems, and maybe a clever transport for these kind of networks could also help. So it's a multifold problem, and we need to be sure on what part of the problem we are working and what kind of solutions we propose. But I think a way to go forward is actually to let the network know what we want, and also to let the application or transports get better decisions by maybe having more information from the network about what's going on or what are the current problems, so that you can, at the endpoints, make better decisions, right? So it's kind of telling the network, here's what I want, and also the network telling back the applications maybe more explicitly sometimes what's going on, right?
Dan Rutte. I agree with Ted about the fact that the more we keep these things separated about the problems that we're trying to address, I think we can come up with better solutions. In the end, the whole idea with this bearer is not just the size of the network. We use templates that are it's the tuning of the resources that are assigned to that specific bearer. And as I said, we are open to see if there's. My previous statement was that it's expensive, and it's not an easy thing to create and delete bearers in real time. In fact, as somebody said earlier, that's not done by the UE. It's something that is controlled by the RAN. So all I'm trying to say is that there's more into it, just the size. It's the tuning of the network, and it would be best if we focus on that. And the hints that we need to get from the application. This was the whole idea with the RTC web, to get a priority, a relative priority. It's not QoS. I think it's very important to understand this. It has nothing to do with QoS. It has more to do with understanding what kind of content is to be able to prioritize it relatively to similar content within the same user flows, as well as in the larger scheme of things. So thank you.
Joe Hildebrand. If the RAN was proactively creating bearers for me, not only is this similar to the multipath questions that we've looked at layer 4, this also becomes very similar to the home net questions we've looked at layer 3. And there may be some interesting things to look at there.
Jana Iyengar. So, the way I see this, and I'm obviously wrong, as maybe everybody in the room or 90% of the people in this room will come and tell me later that I'm wrong, but here's how I see the world now. The network right now gives me a default bearer. The network has other bearers that it can give me to help me do better, to help my traffic perform better over the network. My offering, which was the 0-bit AQM alternative, was to say, you give me a network and I give you a congestion controller that can do better on that particular type of network. When you want the endpoint to tell the network what type of traffic it has, you still have to modify the endpoints, you still have to modify the network, you have to modify the path in between. When you want to deploy a 0-bit architecture, you still have to modify the network, and you have to modify the source of this traffic, because the congestion controller has to change it, should change at one of the endpoints. There are plenty of incentives that are currently aligned with wanting to change the congestion controllers at the endpoint. So in my mind, I am wondering why not just leave the default bearer as the bearer that is handed out to the connection, and have folks, have the congestion controllers and the AQM figure it out from there. This seems to fit the internet model that we have worked with. If that doesn't work, then I'm happy to think about alternatives, but I still want to say that we need to try using AQM and better congestion control first before trying to indicate what seem like simple things as I'm latency sensitive or I'm loss sensitive. I'll give you one example of something that is possibly both. When video conferencing in particular tends to have loss sensitivity as well as latency sensitivity. And it's really hard to classify traffic sometimes into latency and loss sensitive traffic. With transports such as PD and Quick, you multiplex a large number of different applications over the same transport flow. Again, it's very hard to classify this as loss or latency sensitive. So, yeah, I guess that's what I'll come back if I have more thoughts.
Before we go on, just a comment related to scope. And I mean, it's okay to discuss, many things here. We are a, non-working group forming both, so it's okay to have open discussions. But I would like to point out that, I mean, these initial discussions and the scoping of this both was really like, hey, we are doing things. Now we see internet encryption, and we cannot do them, right? We have been moving towards, well, we haven't done these things, but it would be nice to do them, regardless of, whether the traffic was encrypted or not. So just this keep in mind, probably for the ADs mostly, if we want to, continue these discussions in some form, so that we scope them properly going forward. Yeah, go ahead.
Pat McManus. So I think the overriding question, which you're doing a really nice job of summarizing there, almost comes down to, I think it's presented sometimes as TCP has challenges over radio networks, but I would say that that's a specific case of just the interconnection problem, right? Does the transport work over heterogeneous networks, which is what it's designed actually to accomplish in life? And I think we all agree there are going to be some shortcomings there. But stateful attempts to solve that problem in the past, as we've sort of gone through a history with DSCP and some other things, have not been the greatest successes in the history of transport. And we have some really interesting work going on here. We heard about FQ Codal, we've heard, this morning before this session, Bob talking about dual Q and some other things going on in the AQM world. And the IETF is also pursuing deployable changes in transports. You've seen the encrypted transport already with TLS in a lot of places, but RTC Web that uses encrypted transport over UDP provides a deployable way to provide a mechanism to address some of these problems. Google is famously working on Quick in this space, another encrypted transport. I would encourage them to bring that work into this forum so that we can match it against the needs of the radio operators. But those all fall into very broadly the 0-bit category. And they do it without information leakage to the network, which is very, very dangerous, I think, as illustrated by an earlier presentation today. And I really would like to see the IETF emphasis on those solutions first, and data sets coming forward to help quantify where there is a match and there isn't a match before we pursue other information leaking strategies.
Hi, David Olson, Sandvine. It occurs to me we've been talking about multiple bearers as though the scheduling can only happen at the radio. I'm just wondering if we can think about scheduling before we put things in the bearer so that they'll only have to have one. I guess that would require some feedback or measurement of what kind of queuing is going on. Another thought, the use case here that I think is kind of the canonical one for me is gaming versus, say, background stuff. And I haven't heard the scavenger class traffic sort of mentioned here. Maybe it's implicit. That's just something I want people to keep in mind. It's not just I always want low latency or I always want fastest throughput. Sometimes I want something to happen if nothing else is going on. Thanks.
So, Spencer Dawkins, I wanted to do two things here. One is to kind of follow along what Jana was talking about, which was thinking in terms of how good things have to be for people to pull out the mechanisms that they're using today, which kind of disturb us with TCP accelerators and things like that. I'm reminded that those are there for a reason. I'm reminded that NATs were there for a reason, but whether NATs are still there for the reason that they were there for originally, we've still got NATs. I'd like to understand how good things have to be for people to pull out the mechanisms that they're using today and use something else instead that doesn't rely on them. Just for the BOF chairs, could you put me in the end of the line when you guys think we're finished, and let me ask a couple more questions to the group?
Yeah, and I was going to say at some point, and I'm glad to see red dots in the line, this is, from my perspective, an interesting question of how a group like this goes forward, because there's a lot of inter-technology discussion to take place. I think, Spencer, your initial comment about this sounds like it's going to have a lot of experimentation in it. And gladly, I do not have a yellow dot, but figuring out how to run a working group, which is going to have, I think, a lot of IAB involvement and a lot of other organization involvement to get those kinds of experiments done, is an interesting question.
So I built up a immunity to IAB folk by being on the IAB for a little over 3 years, so I'm good with that. And I'm happy to use the dot that I've got now if it's helpful.
Colin.
Colin Jennings, hard space to experiment. I think the things that I've heard that really resounded well with me is, I very much agree with the position of, it's all going to be encrypted and we need to think about what extra bits are there. But when we look at what actually happens today, people look deep into things to classify things into bins for just a couple different behaviors. And it's not this considering and trying to figure out whether your application is low loss or low latency or whatever. That's sort of the wrong axis. There's a couple different bins of behavior, and we probably only need a very small number of indicators to let the network know which one of those categories you're in. We can transport those networks at various layers, things like SPUD, at diff-serve code points, I think are plenty. We've been doing this in voice and video and interactive video and streaming video for a long time in enterprise networks, and had a lot of experience with what happens with the different things. And I think the other point that was really key for me was the one Dan made about not allowing these to be modified along the path might definitely change the situation from what we have been doing. I think that's a very important topic to think about deeply in deciding it. And I'm not caring where we put the bits in the syringe, right? But what's allowed to happen to those indicators, and that the indicators indicate a bin of what's going to happen, not our, that we don't try and just reduce it to the simple idea of whether you prefer latency or loss, because it's not quite that. It's always a little bit more complicated. Thanks. So there were statements made about, like when I hear people say video, I know people instantly are talking about different types of video. Some people are interested in, YouTube streaming, where you grab a little block of data quickly, then wait a long time, and then grab another block of data. And you're interested in a certain aggregate throughput with huge amounts of latencies, doesn't matter, right? There's other type of video, like interactive voice video, where latency is king on all the metrics. If you could move my loss rates up to 10, 20%, I wouldn't give a crap if you could move my latencies down. Right? And it's very pushing the latency sensitive parts down. There's, audio traffic will not exceed, it's a very small bandwidth for audio traffic, right? Like on a matter, we're talking very small kilobits. So video and audio are both low latency, but one is very low bit rate at the same time as one. And we fall into just a couple of these. I think there's like a handful of different categories. There's clearly a category that didn't get talked about, got mentioned. So it's like, I want to download a new update to my operating system. I don't really care. I'd really like that just happen in the background, not mess up my other traffic, right? Yeah, scavenger class. So I think there's a handful of these categories, and there aren't too many of them.
Ted.
Ted Hardy. There are two things I wanted to get up and talk about, one of which was actually related to what Dave was saying about the characteristics of the network and the scheduler aspect of it before you start putting things onto the bearer. And that's actually something we've talked about in RTC Web, and making sure that the browser, which is acting in some sense to mediate the media traffic coming from audio video sources that are being composed, sent across the network, that it do some of the work to consider how the scheduling should be, and at least understand within its own context, given the relative priority expressed by the application, what it should prioritize putting out to the network, or in this case, the bearer. So there are applications where the behavior of the application starts to approach the behavior of a router in determining which queues to drain first. So this is an added piece of complexity in the application, but because it is in the end system, the incentives to get it right very much align. Right? The other piece I wanted to point out was something that actually came up from one of our colleagues at Netflix, which is that sometimes these change mid-flow, right? That the characteristics you need from the network actually can change in relatively short order. And this goes back to what Cullen was saying about video. Interactive video remains latency sensitive throughout its entire run, but as it turns out, downloaded video, once you've reached a playout buffer of sufficient size, ceases to be latency sensitive and becomes quite latency tolerant. But it is incredibly latency sensitive at the beginning of the flow, because otherwise you get buffering. And rebuffering is one of those things that anybody who does video, be it Netflix or YouTube or Vimeo or any of us, whenever that happens, we know our user's unhappy. And so it's important for us to look toward a future where the instructions we give the network about a flow's characteristics can actually change, so that we can say our expectation change. It's also important because we're building these transports like HTTP2, which are multiplexed. And so you might be talking to a particular server using one application at the beginning of a flow and change in the middle. And you don't want to redo the session setup in order to tell the network something new about the flow if you can avoid it. That's something that needs to kind of go from us back to our colleagues in 3GPP2 as an important element of how QCI needs to involve. But it's also something that we need to think about for ourselves as we think about how we talk to congestion controllers or queue selectors. Thank you.
Eric?
Eric Nordmark. So there's clearly is room for experimentation to see, what people have talked about. Can we get to 0 bits? What type of queuing mechanisms can we use, etc. But I actually got up here to raise another question, which I haven't heard discussed. I had to step out for a few minutes on a working group, but which is the sort of dynamic behaviors of the radio scheduler and the what is it called now? The carrier, the tunnel. To what extent that can actually is static when it's established, or whether it can actually be adjusted, because that's a parameter that we don't actually have in typical, IP networks, IP Ethernet networks. When people think about lots of queues and you map things to queues, you then have a hierarchy of the actual carrier, the queuing behavior or the selection of the carrier, and then which behavior you have inside the carrier, but also can you adjust the parameters of the carrier as part of doing this, and when do you do that part? And I don't know if people are already looking at that, but it seemed like, at least I don't feel I understand that, whether that's another sort of knob that people can go tweak.
Bob?
Yeah, Bob Piska. I guess I just wanted to make something exposed that hasn't been exposed, and that's that a number of us have been trying to work on this problem for many years and not really stating it as this problem. We've been trying to do good traffic management, even though no vendor wants to do that because they want to sell boxes that look at all your content but you know, I've been working on this problem for 15 years. There's been a research community that came around the sort of capacity sharing workshop in ACM and things like that that's been working on this problem. And there's a lot of research on it, and it's mostly 0-bit sort of solutions that you know, around AQM, or 1-bit solutions around ECN and AQM. And so there's a lot of work already done on this. It's not new. It's not a new problem, because we've all been trying to not do, or do things better than middle boxes can do them, or at least do them as well as, so that you don't need them.
And I guess just by way of question there, and maybe one of the things we can add to that work, but I take it that work is mostly research that's getting published separately and not shared implementations of some sort.
But for instance, the Connex working group came out of that community. Yeah. And AQN, you know, that, I mean.
I think there's plenty of work that's actually deployed out there too. It's not just publications that are on paper. All of this is code that's deployed. FQCORL that I was talking about is deployed in Linux right now.
Jari?
Jari Akko, felt the weight of the red dot, felt the need to come here and join the queue. So this is an important problem, and as I was listening to Kevin's presentation at the beginning, I was thinking that, wow, there's many things happening. The point that I wanted to make is that actually there's a lot of detail in, you know, the various things that could be happening in the networks, and they're not all the same. So as an example, you know, a plain TCP optimizer is a very different beast from something that actually needs to look inside the content. So I want us to keep that in mind. And the other thing is that I'm sort of reflecting on this as, you know, we are reacting to a change in the internet at, you know, at the particular speed we can do in this organization or in the technical community. And we don't necessarily always think about the full picture. So now, you know, the amount of encrypted traffic on TLS and HTTPS changed in the internet. But it's not necessarily the only change that is happening. I at least see that there's a lot of quick evolution coming down the pipe in the transport space. It seems to be possible to do new things. You know, the quick protocol as an example, and the WebRTC traffic and all of those things. So it's a useful thing to think about that a little bit, not just react to the one change, but the broader, bigger, longer thing. And that actually brings me to not so much of a technical point, but sort of an organizational point, that it might be more useful to try and affect the things that are, you know, coming down the pipe than the current things, because those, by the time that we get them done, those are the things that will be, well, by the time we get the changes to anything done, then those new things will be the ones that are actually being used out there in the real world, and affecting those might be more efficient than the ones that by then would be old stuff. So let's keep that in mind. And I think the really crucial point is that whatever we do in the transport space, that we actually would have this sort of internet-wide or industry-wide discussion about you know, what works, so that it's not just about, let's say, the content providers working on something, but the operators and content providers working on something together. That's important. Thank you.
Thank you, Jari. We are cutting the line. You have exactly 1 minute per person to make your comment. So we are cutting the line. So those 4 people.
Janayangar, I totally agree with the Jari.
So by cutting the line, I mean, I don't want anyone else to join the line beyond the 4 people that were there before.
1, 2, 3, 4.
Yeah, sorry about that. 1 minute, Jana.
Janayangar, I totally agree with Jari that working with content providers and operators working together is the right model to figure out what a good solution space is in here. I just want to say 2 things. I'll be quick. One, I want to reiterate what Bob said in the line earlier. Work's been going on here for a very long time. And if you are walking into the space thinking that this is a new problem, it's not. It's the same old problem in a new context. We've talked about doing latency sensitive and bandwidth intensive traffic together on the same network for years. And we've actually been trying to achieve that. This is something that we are doing not just for mobile networks, we're trying to do this for all networks. So please pay attention, or if please look at the solutions that exist out there for all networks, because they may easily apply to mobile networks as well. The second point is that any bit that we choose to expose, it's not going to be easy to come up with 1 bit or even 5 bits for that matter. The DSCP experiment has shown us that. Any number of bits that we come up with are going to be problematic, are going to be, as Tom was pointing out earlier, are going to be abused. I know for a fact that if one particular bit gives, we'll do experiments, or I shouldn't say we'll do experiments, I say people will do experiments that will try and figure out which particular code point works best for what kind of traffic, and they'll just run with it, irrespective of what that code point is supposed to mean. So, thank you.
Okay. Yeah, thank you. 1 minute.
Linh Linh, China Mobile. I think my comment is that, with DSCP standing alone for years or decades, that we as operators are not using it end to end from outer internet, from the content provider. There's a reason. The reason is that, it's not about who is paying or who is gaining, but for us to safely, to justify which traffic is more important to our subscribers based on our profiling of the subscriber's interest and preference. I think that's the key point here. So whatever you're asking for network to provide, I think it is important to make us to believe or justify that your requirements is fair according to the subscriber's experience. I think that's the key here. So I like Brian's idea that, I'm not sure whether or not his proposal with 1 bit enhancement could work, but I like his idea that there's no incentive to lie or fraud. I think, that's a very good point here. Thank you.
But then, if we all need to get out of this BOF with some message, the one word that comes to mind is trade-off. And it's kind of related to what Brian's presentation was about. That's, we need to be able to, and by the way, the use cases involving network sharing information about its state, its congestion to the content providers have not been discussed enough today. But I think there's a case to take those into consideration. As I said, it's in response to Jana. It's a two-way street actually, and I think having these solutions addressed, maybe we don't address them with the same hammer, but we need to be able to identify and kind of experiment with various specific sharp tools these use cases that we're trying to narrow down. But I think it's a very important subject for us as an operated community. And I agree with Yari in regards to the fact that we have an opportunity to shape the future of the communication protocols, because we are running in a different context. Not that we're running, bits are bits, but the amount and the kinds of bits are totally different. Thank you.
Okay, thank you. 1 minute.
Hello, take about my name. I don't understand why this is specific for 3GPP networks. I think this is very similar in large-scale Wi-Fi access networks or specific satellite networks. New satellite networks are also based on 3GPP, same model. I also don't understand why we are looking for alternatives. We have plenty of solutions, but mostly it's only FIFO implemented. So let's fight FIFO and implement something we already have using DivServ, other kind, ECN, Connex, what is explained. And last words, I think this is about billing. If we want to provide multiple services to users, we have to think about how to offer this to the users. So maybe this is of interest of new approaches, interfacing applications, users with the network, and how to provide services with more value, and how is this cost model.
Okay, thank you. We need the last few minutes for Spencer to basically ask a few questions, so please, Spencer.
So just making sure the mic is still on. These are going to be show of hands kind of questions. I'd love for people to grab me in the hallway at lunch the rest of the week. But just show of hands questions. Was this, Bob, helpful? And by that I mean addressing a real problem. If you could raise your hands. That's kind of encouraging. For the Marnu workshop attendees, did this move the conversation forward beyond last September?
Are there Marnu folks who think not? A couple.
Stephen Farrell and I actually have a bet on that. How many of you have read the Marnu workshop draft report? How many of you are subscribed to the Accord mailing list now or will be very soon? How many of you are willing to help us figure out how many different things we need to do on the Accord mailing list? For background, I expect that the answer is we're going to be doing more than one thing as a result of our conversation here. Good IAB workshops often have more than one output. How many of you are willing to help us figure that out on the Accord mailing list? Thank you all for coming, and thank you, Pete and Gonzalo, for sharing this, and thank the BOF proponents for requesting it. Enjoy your lunch.
Thank you. The meeting is adjourned.
If anyone has not signed the blue sheet, they are up at the front here. And thank you to scribes and jabber and note takers. Very much appreciated. And if the note takers would please email Gonzalo and I as soon as possible.
So Nicholas and Natasha, please email us the notes and we'll put together the minutes.
Up here, yes.
Yeah, I've been meaning to reply to her about that. I don't have, I'm not in work right now, but talk to me. Yeah,
There's clearly
I'm pretty much yeah, absolutely, yeah. I'm yeah, he's heard nothing. It's in my queue, like he's about to want me to speak on email. I'm scheduled up about definitely interested, but you know, work right now. Yep.
Martin Stiemling. Ah, you are still there. Good. I have your device. Spencer now has your device. All right. Good. I think. Yeah. No, let's. Do you have lunch plans?
Yeah, I have to.
Okay. But yes, I'd be glad to join you, Spencer. Oh, and Natasha is right. Right up here. Right here.
Good to see you. Good to see you. Good to see you too, man. How's it going?
Not bad. I can't complain.
Do you have time sometime this week to talk, sit down?
Yeah, let's. Today, I think I'm busy until like 5 or something like that. Or drop me an email with your, like availability.
Yeah, we'll do that. So we'll send you send me an email on that. So.
That'd be great. Otherwise, next week, I think I'm going to be Wednesday in Stockholm. But other than that, I'll be in Helsinki.
Yeah, okay. That would be one possibility as well.
Let's try to do it here.
But
Otherwise,
because it's easier here than.
I know. I know.
Okay, talk to you later.